Hello, my name is Cliffany Smith. I'll be doing an oral presentation on membrane structure. Now, there are four parts to membrane structure. There is the phospholipids, there are proteins, there are sterols, and there are also carbohydrates. Now, the phospholipid bilayer has hydrophilic heads and hydrophobic tails. So, when it's hydrophobic, that means it doesn't interact well in water. And if it's hydrophilic, that means it's water loving, interacts well with water. So now, the movement of the phospholipids, they're not lateral and they don't flip flop across. It basically looks like this. These are the hydrophobic tails and the hydrophilic heads. So the tails usually interact with each other, and the heads, they're facing outward to interact with water. Now, there are two types of proteins. There's peripheral proteins and there's integral proteins. The integral proteins, they're found inside, integral inside, and the peripheral proteins are found on the periphery, or you could also call it like basically on the outermost scopes of it. So now, first I would like to go in depth more on proteins. So we already concluded that we have the hydrophilic heads and the fatty acid tails, which are hydrophobic because lipids and the lipid sterols, they're hydrophobic. So integral proteins, location is inside the fatty acid tails. So it has a hydrophobic R group, because we already concluded that the hydrophobic R groups are going to prefer to interact within the fatty acid tails. So let's just make a note. They have integral proteins and peripheral proteins. We have heads, which are hydrophilic for the phospholipids, philic, and we have the tails, the fatty acid tails, which are hydrophobic. So the proteins, the integral proteins move laterally, but they don't flip across the membrane. That is because it's embedded within this part. And these are just other hydrophilic heads, and we have some tails here and so on. Now, peripheral proteins have hydrophilic R groups. Isn't that something? So that means it's able to interact with water. We can write this here: hydrophilic water loving. I think philic means loving, or yeah, and hydro is water. Hydro and phobic means phobia, so it's like water fearing. Okay, so now we're gonna move on to sterols. Sterols, as we concluded before, is hydrophobic, and the location of these sterols are either attached to the hydrophilic heads on the outside of the membrane. Up here we can have like a A good example would be um, a glycolipid. They're usually found at the like on the top of the hydrophilic heads. They look like they're in like little like segments. And they're also found like cholesterol. They're also found within the bilayer right here. You can find them like looking a little like chain like within it. It moves laterally and it flip flops across. So we have done 3 already. That's right under sterols: hydrophobic, water fearing, and last now we have carbohydrates. So carbohydrates, they are hydrophilic, like cereal. Cereal is a carbohydrate and it just meshes well in milk, and that's also a form of liquid water, you know. So we have carbohydrates being hydrophilic. So now it has lateral movements. Flip flop across? Nope. So the location of these carbohydrates are the end of integral proteins outside the membrane. Integral proteins look more like little channels, and you know, it's a whole stretch of things that like proteins, they have different functions, and you know, it determines what goes across the membranes and stuff, you know. And we have glycoproteins in there, we have peripheral protein, and all those things. But I would just like to look at outer scope of it to get you a picture of it. And thank you very much, and have a good day.